you go. Right. Okay, so what's density? What do you remember about that? Mass over volume. And most of the time in science class, even on other materials, the mass is usually measured in terms of grams and volumes in things called cubic centimeters. So centimeters to the third power. So that's what they look weird, don't they? You have 2 units. But that's not that weird, because don't you have miles per hour when you talk about speed? You actually know that there are some things measured in miles per hour. Well, density is measured in grams per cubic centimeter, and that's what the unit looks like. So what if I gave you a mass of 20 grams, and you knew that the volume was 5 cubic centimeters? Okay, now what would the density be? For what though? 4 grams per cubic centimeter. They don't go away, do they? They didn't cancel out, did they? And they don't go away. Now, on the test, I might make it a little harder, because what if I were to use significant figures? Okay, now, here's what I'm... Yes, Yeah. Sure. I think so. All right, 5 minutes. So let's make it a little bit harder. If I was in math class, it'd be pretty easy like this. But what if I said that it was, what if I said it was 20.0 here, and what if I said this was 5.0? Okay, let's try that. Now, what's the difference? The difference is, if you use, remember significant figures, that's measured numbers. When you multiply or divide, you have to round to the least number of sig figs. So how many sig figs does 20.0 have? How many sig figs does 20.0 have? I'll give you a little review. Any number is not a 0, that's significant. There are no Oreo zeros on that. So the hard rule was number 3, right? Trailing. Do you have any trailing zeros? That means zeros that come after a sig fig. Do you see any? Yeah, both of them, right? Both of these are trailing. And when do trailing zeros count? When there is a decimal. Is there a decimal? Then you're in. So how many sig figs does this have? 3. And how many does this have? 2. So I have to round to the least number, which is how many? That's 2, isn't it? So we go over here, and I'd have to write not 4, but what? I'd have to write 4.0, wouldn't I? How many sig figs does 4.0 have? 2, isn't it? Okay, so that's how I can make a density problem a little bit harder, is to use significant digits. Okay. All right, do you remember, I have a question on the test like this. What if you put in there 30 milliliters of water, and then you put a rock in there? Are these the same numbers I used before? Look on that handout, look on that sheet. Did I just start at 30? Yes. All right, and then I put a rock in there and it went to what, 37 or something like that? Why did the water go from 30 to 37? I didn't put more water in there. And this is called finding the volume of an object by water displacement. So what used to be where that rock is? What used to be there? Water. Where is it? It was displaced, wasn't it? It was put somewhere else, wasn't it? Now, how much water was displaced? Say it again. You said it. 7 milliliters of water were displaced. So therefore, what is the volume of the rock? 7. Excellent. Does that make sense? That's actually, Archimedes had a lot to do with that. And this is called finding the volume by water displacement. Okay, that's a review. Now, the last thing I want to do has to do with this handout sheet here. And I want you to know metric units, okay? Now, you might ask yourself, well, why is there a paper clip on this handout sheet? And if you look on my handout sheet, why is there a paper clip? Because what? Look on the back of that. Look at the single page. Okay, see this right here? Why would they put a paper clip here to try to teach you the metric system? how much is a why paperclip?
1 gram.
That's it. It's 1 gram. All right, everybody got that? So if someone said, "How much is a gram?" I know what you think is cute. Here's what's cute. I don't know, but metric. Maybe that's cute, but you don't live in that world. You live in a world that everybody in the world knows what a gram is, and you think it's cute because you say, "I don't know anything about the metric system." You have to. You have to. You will interact with the metric system in your lifetime. You get that? It's going to happen. So you can't say, "I don't know what a gram is." Now, I wish I had a nice picture of a nickel. Why did I say something about a nickel? What's it say? What's a nickel?
5 grams.
Well, and they didn't do that on purpose, but a 5-cent piece happens to be 5 grams, and it just happened to be. So now I know about 5 grams. All right, let's go a little bit bigger. I'll tell you that, what if I took a whole liter of water? What if I took 1 liter of water? How much would that weigh? And here's a liter, okay? How much would that weigh? And they did this on purpose. All the stuff they did was to make it simple. And it's going to be a whole lot more than 5 grams, isn't it? Wouldn't it?
1 kilo.
What is it?
1 kilo.
You are exactly right. Excellent. 1 kilogram, which is also known as 1,000 grams. They did it on purpose. They wanted a liter of water to be one kilogram of mass. A kilogram is 2.2 pounds, just by the way, if you want to know what it was. It's about 2.2 pounds. All right, let's go over here now. Why is there a picture of a doorknob or a door? Help me out here, okay? I want you to understand it's not that hard to estimate metrics. How about a newborn baby? How many kilograms? What? What? I don't know metric stuff. What do you think? 2.2 pounds is a kilogram. What if your baby was 6.6 pounds? 3. So 3 kilograms would be a normal, kind of a nice sized baby. 4 would be a little heavier, wouldn't it? So between 3 and 4 kilograms, that's a baby. That's a brand new baby, like that. Okay, now let's go over here. Why is there a door? Yes?
Wait, what did you say? Was it
Oh, if you want to know how many pounds it is, I'll put 2.2 pounds, but we'll do that a little bit more in that next chapter. But a kilogram is about 2.5 pounds, 2.2 pounds. So if I had a baby that was 6.6, that would be 3 kilograms, wouldn't it? Okay, now let's go over here. The door, not that they had to, but humans kind of like their doorknobs to be right about there. So why is there a picture of a door in this page? Come on. 2 people have been doing all the answering. Why is there a door? Isabella. How much? And how much is that? Yes. So you can't say, "I don't know what a meter is." There it is. What if I ask you how tall the ceiling is right now? Oh, I don't know the metric. Yeah, you do. Look at the doorknob. Watch. Look at my fingers. 1, 2. Ooh, just a little bit short of 3, isn't it? It's about 3 meters. The top of the ceiling is almost 3 meters, isn't it? I just want you to relax a little bit and say, "That's not so hard. That's not so hard." Which one's bigger, a meter stick or a yardstick? A meter stick by a lot? Don't be dumb, okay? What is it? What does it say? A yardstick's 36 inches long. A meter stick is 39.37. It's like, ooh, that's about a little more than 3 inches, isn't it? So a meter is about 3 inches longer than a yard. Okay, I can remember that. All right, what about your finger? And I don't like to use fingernails, but I do like to use something like, when I use this in the next lab, you'll have a ruler like this. And I know it's cute. It's certainly cute in middle school. It's not really cute in the 10th grade to say, which side of the ruler is metric? Okay, I'm going to show you so you'll never have to say that again in your life, okay? Your little finger, if you lay it sideways, should be close to a centimeter. See that? Now, there is nobody, if you say, which side is metric, I'll say, let me see your little finger. There's nobody in here whose little finger is that wide, is it? Is it? You know that's English, isn't it? That's inches, isn't it? So now you know those are centimeters. Now, you know what a centimeter is? Okay, next. Why is there a picture of a dime? Why is there a picture of a dime? How much is it?
1 mil.
A millimeter. Oh, I get it. I get it. A millimeter. That's this little guy, isn't it? I get millimeter, centimeter. I'll give you one that's not on there. Look at this. Here is a tenth of a meter, right there. What would you call a tenth of a meter? What's the prefix that means 1/10? What prefix means 1/10? Kyle, you know this one. What prefix means 1/10? Say it again. Oh, by the way, if you don't know your metric prefixes, you're not going to do well on the test, okay? We already had flashcards, we had quizzes, right? You have to know those. Deci means 1/10. And if that's a meter, guess what this is? It's a decimeter. All of you have a decimeter. Most of you, if you put your thumb together, that's very close to a decimeter. Get that? All right, are you okay with that? So millimeter, centimeter, decimeter, meter. What's a kilometer? Ooh, that's like 1,000 meter sticks, isn't it? Meter stick, do that 1,000 times. Ooh, look down here. Which one's longer, a mile or a kilometer? And say, well, I'm not sure about that. If I were to draw a picture of a mile, and I drew a picture of a kilometer, which one's longer? Hey guys, which one? Which one's longer? You say, I don't know. I don't think I know. Well, the whole world knows, except for you. Anyway, it's a little over half a mile. So if you can estimate a mile for me, go a little bit more than half a mile. Go 6/10 of a mile. That's what a kilometer looks like. Now, if you do, and I think they will be going back to Italy. If you go to Italy and there's a bus trip and they say, we're going to go 100 kilometers in the bus. You said, whoa, how long is that? Well, first of all, since kilometers are smaller than miles anyway, if it's 100 kilometers, it takes more kilometers to go that distance than it does miles. So it's going to be less than 100 miles. And how do we know that? And there's a little fraction you can use called 3/5. So if I had kilometers and I had to change it, does anybody know what 100 times 3/5 is? Are you good in math? Can I show you how to do this real fast? Much?
60.
How much?
60.
Yes, you are good in math. Now, here's what I did. I took the 5, I canceled out 20 here. 3 times 20 was 60. Can you do that? Is that how you did it? Or you did it differently?
I did
300 divided by 5?
300 divided by 5 and then I took the 0 out.
Okay,
30 times 5. Oh no, 30 divided by 5 plus 0.
I like that. Very good. Okay. Anyway, so, by the way, if I drive my car at 60 miles per hour, I'm driving it at 100 kilometers per hour. And that's an easy one for me to remember. If I drive. If I drive at 60 miles an hour, now if I was in another country, that'd be 100 kilometers per hour. All right, we're almost done here. This one I might make as bonus. I don't know if I want you to know that or not, but around the world, when they want to measure like the area, like how much land do you own? Here we actually use acres, don't we? If you live in a subdivision and the houses are kind of close together and the yards are not that big, you probably own 1/3 of an acre, maybe a half. But if you have a yard where people could come over, they could actually play football in your yard. All right, toss a football, then you probably have an acre. If you have a house with people can come over, hey, let's play kickball in my yard. Okay, you probably have an acre like that. Now, nobody in the world cares about acres. So they use this thing called hectares. And a hectare is, what I like it is, it's a hectometer long. You know what a hectometer is? 100 meters long, and it's 100 meters wide. Oh, I can envision that. Here's a meter stick. I'm gonna go 100 meters that way and 100 meters that way. I got it. That's a hectare. That's about 2.5 acres. You don't have to know that. And the last thing I want to do is talk about this liter. What is this picture trying to tell you? A liter is bigger or smaller than a quart? A lot bigger? Is a whole lot of it's overflowing or a little bit's overflowing? And right, a liter is a little more than a quart. 1.06 is a little bit more than a quart. So if somebody said, how many liters are in a gallon of milk? Oh no, but the metric stuff. Don't do that. You said a liter and a quart are very, very similar, aren't they? If there's 4 quarts in a gallon, there's about 4 liters, isn't there? That's all I want you to do. I want you to just kind of be, oh, I can do that. And the last thing I want to show you is this box. And then we can go outside if you want. So we have this box. And this box is called a liter. And I think I have this picture written, don't I? Is that picture on your handout sheet? Okay. On this one? Is it on this single sheet? Flip it over and see what it looks like. All right, everybody got it? When they made the meter, they did something that no other measurement system had ever done. If you wonder why the whole world used the metric system, they did something that nobody else had ever done. They made it so simple that anybody could learn it. And one thing they did that nobody else had done, they took their meter and they said, that's for measuring distances. Now we need to measure volumes. Well, you can't measure volumes with a stick. Let's make a box. They could have made a box 1 meter long, 1 meter wide, and 1 meter tall. But you know what? Nobody would ever use it. It would be too big, wouldn't it? So they said, let's make it smaller. How much smaller? You have to stay at powers of 10. If you don't make it 1 meter long, you have to make it 1/10 of a meter long. And they did. They made this box 1/10 of a meter long, and they made it 1/10 of a meter wide and 1/10 of a meter high. And that's how you can make them. If you have one of these, you can make one of these. See that? Now, let's try it again. This is called 1 liter. Very close to a quart, isn't it? And you know that they took 1/10 of a meter stick and made it 1/10 of a meter long and 1/10 of a meter wide and 1/10 of a meter high. You know that, right? Now let's see if you know powers of 10. 1/10 of a meter equals how many centimeters? Wait a minute. I have one right here. How many? How many centimeters across this thing? What do you think? 10, yes. 10 centimeters long. 10 centimeters wide. Now, I'm not asking you to memorize these. Just remember that and know powers of 10. How many millimeters? Oh, I forgot decimeters. How many decimeters? Oh, 1 decimeter. So let's take a look. If you had to find the volume of an object that had 90-degree angles to it, you know that volume equals length times width times height. Is that correct? Okay, what's the length in decimeters? 1 decimeter times 1 decimeter. So you could call this a liter. You could also call it what? What's 1 times 1 times 1? 1. What's a decimeter times a decimeter times a decimeter? It's the same as x times x times x. What is it? See that? It's a decimeter to the 3rd power, also known as a decimeter cubed, also known as a cubic decimeter. That's what this is. It's a cubic decimeter. Now, I didn't memorize this. I just did a little math, didn't I? Let's do this one. What's 10 centimeters times 10 centimeters times 10 centimeters? What's that? What's 10 times 10 times 10? You're right. And what's a centimeter times a centimeter? And that's what this is. This is 1,000 cubic centimeters. Now, 1,000 cubic centimeters can also be written as 1,000 milliliters. You know why? A cubic centimeter is a milliliter. If you work in the hospital, they would call it 1,000 cc's, because they use their own abbreviation, and they call a cubic centimeter a cc. So if you watch a medical show, and they said, hey, give him 10 cc's of something, what do they mean? 10 cubic centimeters, 10 milliliters. I'll show you something here. See this right here? See that? How many of those will fit in here? I'll give you a clue. 10 go that way, and 10 go that way. How many on the bottom floor alone? 100. How many floors? 10. How many of these will fit in there? Then that must be called a what? If 1,000 of you fit in there, you must be a milliliter. You're 1,000th of a liter, aren't you? But a milliliter is a cube that's 1 centimeter long and this is a cubic centimeter. The box is 1,000 cubic centimeters. It's 1,000 milliliters. You get it? Same thing. Anyway, so this is the liter box. All you had to know that you knew they'd made it out of 1/10 of a meter, or you saw a decimeter or 10 centimeters like that. That's about it. I think I'm done. Now, what I did notice, I took 2 practice tests from my files the students had made over the years, and I found 2 mistakes. And when we go outside, I'll try to have you fix them. And well, if we go outside, we're going to work, and I'm going to give you a practice test, and we're going to try to do them together. If you have a calculator, I have no idea which space is available, so we'll go out here first. And if that's not available, then we'll go somewhere else. Yes?
So for our test, would you want us to know this packet very well?
The packet is what's going to be on the test. Now, do I have a couple vocabulary words from the chapter? I do. You could go through and look at vocabulary words from the chapter, but probably 98% of the questions are stuff right from there that we use to study with, okay? That's a great question. And remember, what are we doing tomorrow?